Let us now learn about operations on real numbers. What operations we can perform on numbers? We can perform addition, subtraction, multiplication, and division, right? We know there are rational numbers, the numbers that can be represented as ratio of two integers, and there are irrational numbers. Those are the numbers that cannot be expressed as ratio of two integers, right? When you put together these two sets of numbers, what you have is real numbers, right? Real numbers are a collection of rational numbers and irrational numbers. Now let's learn about operations on rational numbers first, and then look at operations on irrational numbers. Rational numbers addition, let's see. Add 1 by 5 and 5 by 3. It means we want to find the value of 1 by 5 plus 5 by 3, right? Look at the denominators here. 5 and 3. What is the LCM of that? 15, right? So I can write 1 by 5 plus 5 by 3 as a rational number with 15 as the denominator, right? Now let me divide, let me consider this one here and write this 15 divided by this 5. 15 by 5 plus, consider this 5 now, and this 15 divided by this 3. So we can write this as 1 into 3 plus 5 into 5, right? This can be now written as 3 plus 25 divided by 15, that is 28 by 15. 28 by 15 is a rational number, right? Because it is a ratio of two integers. Now what I can say is, when I add a rational number to another rational number, what I'm getting? I'm getting a rational number. This is true for any of the rational numbers you consider. That's why we say that addition of rational numbers is closed. When you say closed, for example, we know that this is, let's say, a set of rational numbers. You take any of two rational numbers and sum them. The solution is going to be another rational number sitting somewhere in the set of rational numbers. That's why it is called closed. For example, if you add two rational numbers and if you are getting something else outside this set, then you may say that it is not closed. But the scenario here is rational numbers plus rational numbers is always going to give you a rational number. That's why we say that addition of rational numbers is closed. This is closure property. Let's now learn about subtraction. Let's subtract 3 by 4 from 5 by 6. It means we have to write 5 by 6 minus 3 by 4. We want to find the value of that, right? Look at the denominators. Okay, what is the LCM of that? 6 and 4 ka LCM is 12. 6, 4. Right? Then you have nothing common among 3 and 2. So 2 into 3 into 2, that is 12. That's why we have written LCM 12 here. Now I am going to write 5 into 12 divided by this particular 6 minus 3 into 12 divided by this 4. So I can write this as 5 into 2 minus 3 into 3. So 10 minus 9 by 12, that is equal to 1 by 12. Now I can say that 1 by 12 is also a rational number. If you subtract a rational number from another rational number, what are you going to get is a rational number. You can take any of the examples and see this is going to be valid. For that reason, we say that subtraction of rational numbers is also closed. Understood? Now let's look at multiplication. Multiply 7 by 5 by 3 by 2, or multiply 7 by 5 with 3 by 2. It means we want to find the value of 7 by 5 into 3 by 2, right? So when you have two fractions like this or two rational numbers like this, when you want to multiply, what are you going to do? You're going to write the numerator as product of the numerators and the denominator as product of the denominators, right? For that reason, it is going to be 7 into 3 divided by 5 into 2. So this is 21 by 10. 21 by 10 is also a rational number, right? So now I can say that rational numbers into rational number is going to give you rational number. This you can check. Any rational number combination you can take and verify this. You are going to get this. For that reason, we say that multiplication of rational numbers is also closed. Understood? Now let's look at division. Divide 3 by 5 with 4 by 5. Meaning 3 by 5 divided by 4 by 5 we want to do. Look at this. 4 by 5 is the divisor, right? So multiplicative inverse of divisor 4 by 5 is 5 by 4. When I say multiplicative inverse, what it means, for example, 4 by 5 is the number. And if I multiply with 5 by 4, the answer is going to be 1. If I have a number a, its multiplicative inverse is going to be 1 by a because the product is 1. Understood? So 4 by 5 ka multiplicative inverse is 5 by 4. Now what I am going to say is, instead of dividing 3 by 5 with 4 by 5, what I'm going to do is I'm going to multiply 3 by 5 with 5 by 4. Instead of division, I'm making it a multiplication problem. Instead of dividing with 4 by 5, I'm going to multiply with 5 by 4. When I do that, this is a simple multiplication problem, right? We have seen the numerator is going to be product of numerators and denominator is going to be product of denominators, right? For that reason, it is going to be 3 into 5 divided by 5 into 4. It means 15 by 20. Otherwise, I can cut these two 5s. 5 and 5 are getting cancelled. What I have is 3 by 4. Now, can I say that 3 by 4 is a rational number? For that reason, can I say that division is also closed? Division of rational numbers is also closed? No. The reason for that is, look at this problem. Divide 3 by 5 with 0. 0 is a rational number, right? I'm dividing a rational number 3 by 5 with 0. Since the value of this particular division is not defined, we don't know, what number you are going to get in this case, right? You are not going to get certainly a rational number because we have no idea when you divide something with 0, what is the answer? You don't know. For that reason, you say that in the case of divisor 0, actually rational number divided by rational number is not defined. For that reason, we say that division of rational numbers is not closed. Understood? Now let's look at irrational numbers. Addition of irrational numbers. Find value of root 3 plus root 3. Root 3 is an irrational number, right? So root 3 plus root 3, I can write it as root 3 times 1 plus 1. What I have done, I have taken root 3 as the common factor from both the terms. When I do that, what I have is root 3 times 2. That can be written as 2 times root 3. 2 times root 3 is an irrational number, right? Now look at this problem. Root 5 plus minus root 5. Okay, we are adding root 5 and minus root 5. Both are irrational numbers. But when you add them, what are you going to get is 0 as the answer. 0 is a rational number. For that reason, we can say that in this particular case, we have seen that irrational number plus irrational number gave us rational number, right? Meaning if I have a set of irrational numbers, if I take two numbers from irrational number set and add them, I'm going to get something which is rational. It is true for certain numbers, not for all numbers, right? Even then, we say that addition of irrational numbers is not closed. Meaning, when you add an irrational number to another irrational number, you are not sure whether you are going to get irrational number as the sum or rational number as the sum. We don't know that. For that reason, you say that addition of irrational numbers is not closed. Understood? Now let's look at subtraction. Find value of root 5 minus root 2. It is tricky to subtract like this, right? But we know that these irrational numbers, root 5 and root 2, can be written in their decimal form, right? Root 5 is 2.236 and so on. It is a non-terminating, non-recurring decimal. That's why root 5 is an irrational number. And root 2 is also an irrational number. Its value is 1.414 and so on, right? Now let me subtract root 2 from root 5 using these decimal expansions. When I subtract, what I'm going to get is root 5 minus root 2 equal to 0.82185 and so on. This is also an irrational number, right? Can I now say that subtraction of irrational numbers is closed? Answer is no. Why? Because, I can take this example. Find the value of root 5 minus root 5. Root 5 minus root 5 is 0, right? It is a rational number. When I subtracted, in this case, an irrational number from another irrational number, I got a rational number, right? For that reason, I say that subtraction of irrational numbers is also not closed. Please note this. Now look at multiplication. Find the value of root 3 times root 2. Root 3 can be written as 3 power half, right? Square root symbol దేనికైనా రాస్తే కనుక దాని మీనింగ్ ఏంటి? స్క్వేర్ రూట్ ఆఫ్ ఏ అంటే ఏ పవర్ హాఫ్, స్క్వేర్ రూట్ ఆఫ్ బి అంటే బి పవర్ హాఫ్, స్క్వేర్ రూట్ ఆఫ్ 3 అంటే 3 పవర్ హాఫ్, and square root of 2 అంటే 2 power half. Now look at this. Powers of these two numbers are same, right? Half is the power. That's why we use this formula. A power m times b power m equal to ab whole power m. When the powers are same in the multiplication problem, you are going to multiply bases and put the same power, right? In this particular case, it is going to be 3 into 2 whole power half, meaning 6 power half, that is equal to square root of 6. Square root of 6 is an irrational number. Based on this, can I say that multiplication operation is closed for irrational numbers? Let's wait. Let's look at another problem. Find the value of root 2 into root 2. This can be written as root 2 whole square, right? It means it is going to be 2 power half whole square. That can be written as, when you have this a power m whole power n, that can be written as a power m n, right? In this case, it is going to be 2 power half times 2, that is equal to 2 power 1, that is equal to 2. Now you see, I have multiplied two irrational numbers. What I got is a rational number, right? For that reason, now I can say that irrational number and times irrational number can give you sometimes rational number. That's why multiplication of irrational numbers is also not closed. Understood? Now let's look at division problem. Find the value of root 6 divided by root 2. This I can write it as root 6 divided by root 2. We know this formula. A power m by b power m, that can be written as a by b whole power m, right? ఎందుకంటే power అనేది రెండిట్లోని సేమ్. That's why we can write it as a by b whole power m. ఈ పర్టికులర్ కేసులో 6/2 whole power half గా రాయొచ్చు, రైట్? స్క్వేర్ రూట్ అంటేనే పవర్ హాఫ్ అని కదా చెప్పుకున్నాం. సో 3 power half, that is equal to root 3. So we got irrational number, right? Now let me consider another example. Square root of 7 divided by square root of 7. Its value is 1, right? It is a rational number. So for this example, you have seen that irrational number, when you divide an irrational number with another irrational number, you got rational number as the answer, right? So now we can say that division of irrational numbers is also not closed. You look at this. In the case of rational numbers, only division is not closed, right? For rational numbers. For irrational numbers, all operations are not closed, right? Rational numbers, addition, multiplication and subtraction, they are closed, but division is not closed. When it comes to irrational numbers, addition, subtraction, multiplication, division, none of them are closed. Please note this.